Today we're continuing on through the AAMC's official MCAT study guide going through psychology. Small today is going to be teaching us about consciousness.
Yes, which is the awareness of our world and our own existence in it.
So is there a physiological definition of consciousness, or is it a psychological definition of a physiological state? And the third option, did that make any sense?
It did make sense. And I think it's more of a psychology term because I think physiologically, like we would just say, said person is awake. And,
arousal, right?
Right.
Okay.
And then, conversely, like they're in a coma or they're sleeping.
Yeah.
And there are physiological things that go along with our states of consciousness. So, yeah, I guess you could differentiate between them based on physiological symptoms.
Okay. All right. So what are states of consciousness?
So the mnemonic for it is SAD. There's when you're totally asleep. So sleep is S. There's alertness when you're awake and aroused, A. There's another A for altered. We'll come back to that. And then dreaming would be the last one. So you're asleep, but there's something going on in your noggin that is not active cognitive function, cognitive just being thinking. So going back to the altered consciousness, that would be things like delirium, sickness, dementia, coma. And I think delirium is like when there's something physiologically wrong within your body, and you have an altered state of how you're thinking.
Right.
Yeah.
So these states of consciousness look like they come out of, it's your physiology affecting. So consciousness is kind of like the umbrella term, right? It's like,
yeah,
it's kind of like how your mind is in the world, basically, and then based on your physiology, it could put you into one of these states, which is either sleep or alertness or the altered or dreaming.
Exactly. And Tal has an experience with delirium, I believe, due to a medicine, was it?
Yes. So when I had swine flu back in like 2009 or 2010, when it was really going around, they put me on a medicine, and I remembered hearing at some point that a lot of kids were having really weird adverse side effects to the medicine that were reported as psychedelic experiences. And I was put on the medicine, and I remembered I'd been at home for 3 days. I was really bored. A friend of mine like invited me to just go out, just to do anything, and I was totally down. So I went out, and we ended up at PetSmart somehow, and the medicine started to kick in. The first thing I noticed was that the entire world just turned upside down while I was walking. It wasn't that big a deal, but I was just walking through this upside down world, and then I got really hungry, and I saw this little buffet of human cookies that they just put out for some reason. Turns out they weren't human cookies. So that's my experience with delirium as an altered state of conscious.
Do tell exactly what the cookies were.
Oh, the cookies were dog biscuits.
There we go. So that would be classified under altered consciousness.
Right.
You were aware of your world and the existence in it, but it was not quite the same world that you would be experiencing right at this moment.
Yeah.
After some coffee.
And it kind of felt real. It felt normal. And I really thought like, okay, yeah, they just have cookies out here for people to eat. And so I started eating them, and they tasted kind of weird. I had probably 3.
Oh my goodness. So the opposite of the first one that we talked about, sleep, would be alertness and awake and able to think. And so when I think about alertness, when I think about, the physiological side of alertness, I think about cortisol being higher because I know it raises throughout the night, and then it's at its peak of our day, when we are waking up.
Yeah.
And then I think about the role that melatonin plays. It's kind of the opposite, right? It rises right before we go to sleep.
And that's a good point that I always harp on this with people about melatonin, that melatonin doesn't put you to sleep. It's like it's at the scene of the crime, but it didn't commit the murder kind of thing. Melatonin sets the body up to be ready to go to sleep, kind of like cortisol sets the body up to be awake.
Yeah.
It like gets all these processes going, just like melatonin like gets everything ready for sleep. But it really is, and the little graphic that we're looking at here specifically has daylight and nighttime. And I think that's actually more important than people give it credit for, that it really is light that hitting our photoreceptors that tells us asleep or awake.
Yeah, there is an actual pathway that we'll talk about in actually a few seconds. I think it's on this one. That starts with the photoreceptors in our retina, and ends up getting routed, I think, through the hypothalamus. And then there's like a chain of different things that allows us to start producing cortisol to wake up, or conversely melatonin to fall asleep. And so you said it kind of, it's at the scene of the crime, but it didn't commit it.
Yeah.
The murder. And so there is a certain amount of keeping up with our circadian rhythm that we need to do, right?
Yeah.
So like we need to actually go to bed when it's dark outside and wake up when it's light outside.
And when people say, you know, like, oh, I'm just a night owl and I just like to sleep like throughout the whole morning and some of the afternoon, but I stay up all night, even if they're getting the you know, quote unquote proper amount of sleep, it's still like it might not be affecting them right now, but you're very likely to see some down the road effects because we are not made to do that.
Right.
We have to respect our biology.
Yeah, their physiology is literally different.
Yeah.
Okay. That is a very good point. And so I'm sure like nurses that work night shift or people who work third shift at like the railroad
Right.
might struggle with more things than someone who is in the exact same situation but works day shift.
Yeah.
So that maybe they might have a harder time losing weight, or a harder time just, you know, because they can't
Easily.
stay awake when they're supposed to, so they drink all sorts of caffeinated beverages.
Then you get cortisol, all kinds of messed up, and cortisol is a huge regulator of putting on weight and metabolism, things like that.
Yeah. So we have, when we do go to sleep when we're supposed to, we have a 90-minute sleep schedule, and we kind of look at this from looking at brain waves on an EEG, so an electroencephalogram. Did I say that right?
Electroencephalogram.
It's just like I can't say generalization.
So an EEG, right?
Yes. And so we have characterized the waves that denote when someone is awake, and the difference between like a sleepy or relaxed awake versus an awake when I'm doing calculus or something, you know, that stimulates my noggin.
Mm-hmm.
And then we've gone into, you know, how the waves are different when we're sleeping, and then we've broken it up into different stages of sleep.
Right.
So do you remember what our awake waves look like?
I know that. I don't know what they look like.
Do you remember what they're called?
I know it's beta and alpha.
Mm-hmm. Which one is when I'm doing calculus?
I'm just going to guess alpha because it's first.
Yeah, so I thought it would be super simple if they had named it that way, because I remember that, like, alpha people go hard and get things done. But it's the opposite. So beta is the one that is doing its thing in our noggins when we are using our working memory and doing something that requires a lot of cognition, like math.
Okay, and that's going to make... I do remember beta having something to do with REM sleep, which I'm sure we're about to get to.
Yep.
So, okay, beta is really active. Alpha is like you're awake, but just not really trying to concentrate on something, process something.
Yeah, they always equate alpha to when you're laying down and trying to fall asleep, or if you're kind of zoning out when you're watching a TV show and about to fall asleep or something, when you're relaxed but you're still awake.
Okay.
So the first wave that shows that we've fallen asleep is our theta waves.
Mm-hmm.
And so we're going to start, you know, with stage one is the first part of sleep where we see theta waves, because before that it's just alpha.
Mm-hmm.
And then stage two, it would be when we start seeing something called sleep spindles, which are literally like little up and down. It reminds me of an EKG.
Yeah.
Those spindles. And the K complexes, which are just two distinctive things in an EEG.
Mm-hmm.
And so that's how they characterize the first two stages.
And I do remember that when we've taken tests before, when we've taken a lot of practice problems, they'll say something about sleep spindles and K complexes. What they want you to know that it's like stage 2 of sleep. It's theta waves that are doing that. Okay.
Yeah.
Early sleep.
Yep, early.
At least in the cycle, because we have many cycles throughout the night.
Exactly.
Early in the cycle.
Yep. And so stages 3 and 4 are characterized as slow wave sleep, which is something that I really like talking about because it directly affects something that I dealt with when I was a little one, even though I don't remember it.
Mm-hmm.
My parents remember it very well. And slow wave sleep is when it's very restorative. And it's when the waves are literally longer. There's a longer wavelength and a lower frequency.
Mm-hmm.
And so there's very few waves per second. And so they're also non-rapid eye movement. And children spend a lot more time here in slow wave sleep. So that's why people with night terrors and somnambulism, which like those two things happen more frequently in slow wave sleep. So because children spend more time here, children that are at a higher risk for it.
Mm-hmm.
And I actually had night terrors so bad, my parents were going to take me to like a priest for like an exorcism or something. They thought it couldn't be medical. And the pediatrician was like, yeah, this is something, it's like a developmental thing. They'll grow out of it, or she'll grow out of it. And they were like, no, this can't be possible.
And I had somnambulism so bad that my parents had to put really special locks very high up on the door all the time because I might fall asleep and then end up in the road, which I did one time.
Which is just kind of a little dangerous.
Yeah.
So the other thing about slow wave sleep is that, well, not necessarily slow wave sleep. That was a lot of S's. But the way that children sleep is that, you know, we as adults have a 90-minute sleep schedule, sleep cycle that repeats over and over, but they actually have a 50-minute sleep cycle.
Mm-hmm.
So I wonder if the fact that their cycle is shorter actually throws them into slow wave more frequently because they just have more cycles per night.
So throws them into it more frequently, but same length, like maybe cycles 1 and 2 are shorter?
Yeah, I don't know. Maybe. Like the stages 1 and 2?
Or stage 1 and 2, yeah. Huh.
Yeah, I don't know. I don't know why it happens, but I thought that's really interesting.
So we have stage 1 and 2, which are dominated by theta waves.
Mm-hmm.
And I guess outside of like when you first fall asleep, I'm not really sure what their importance is. However, then we have stages 3 and 4, which is very low frequency delta waves. We're getting more restoration. That's probably where a lot of healing takes place and a lot of like recycling in your body takes place. Then what?
Cleaning our synapses also is in slow wave. Really quickly, you mentioned delta, and I'm so glad that you did because I just glanced at my notes. I realized I totally skipped over saying that stages 3 and 4 were delta.
Yes.
So the reason that we know we've actually fallen asleep, or that sleep doctors know we have when we're hooked up to electrodes, would be that we see theta waves in stages 1 and 2, and we characterize 2 by those sleep spindles and those K complexes. Mm-hmm. And then we know that we've entered slow wave sleep when we start seeing delta waves. So thank you for catching me on that. So when you read about the stages, they always put REM sleep at the end, which would be rapid eye movement sleep. And because it was at the end, I always thought that it was at the end of the cycle and it was the deepest part of sleep, which is paradoxical to me because the brain waves in REM sleep mimic us when we're awake and using working memory and when we have beta waves. So when we're doing something that requires a lot of cognition. So
it's not just like alpha awake, like sleepy awake. It's like you're very
you're working hard.
Active.
Yeah, which I think is so interesting. And that's when people have really vivid dreams. Like 70% of our dreaming happens in REM sleep. So that makes a lot of sense. But we're still asleep, right? You couldn't wake up and go, well, I guess if you had somnambulism, you could do lots of different things while you're sleeping. But the majority of the population cannot wake up and like make breakfast or do their calculus homework or whatever when they're in REM sleep. But physiologically, they're awake. Their brain is working like they're awake. They might be, breathing faster. Their eyes are flitting back and forth.
Yeah.
So, yeah, it's called paradoxical sleep for that reason. And it actually, when you look at a hypnogram, which I think is a funny name, when you look at a hypnogram of sleep, which I would highly suggest that you guys do if you get a chance to, it kind of puts things in perspective. So your awake is at the very top, and then as you go down, the first thing you reach is REM sleep. So it's really like almost between awake and the 4 stages that we previously talked about.
Yeah.
And I guess I had the misconception that REM was at the very bottom because we always talk about it last and it's supposed to be like the deepest part, but not necessarily.
I think the like misconception that people have is that we call them like REM cycles. And I think it just basically means if you get into REM, that means you've you've done deep sleep and you've successfully like done that restorative period for your body. So for health reasons, getting a REM cycle is good because it means you have successfully completed a deep sleep, cycle.
Yes. Yeah. So we mentioned that it was really important to kind of go along with how your circadian rhythm works because you are physiologically primed to work that way. And so we have a 24-hour cycle, and I'm sure that does actually change from like organism to organism, but at least for humans, it's a 24-hour cycle. So we talked about the pathway too, and you mentioned the photoreceptors. I thought this was fascinating.
Mm-hmm.
So in the dark, our retinas, our rods perceive that there's a lack of light and then turn off, and they send that signal. But there's part of our optic tract that actually routes through the hypothalamus, which I think is fascinating. I had no idea it works that way. And we know the hypothalamus controls the pineal gland, which Tall taught me produces melatonin.
Mm-hmm.
So when it's dark, the rods send the message through the optic tract all the way back to, it'll eventually hit the occipital lobe, but before it gets there, a little part of it passes through the hypothalamus, which tells the pineal gland, hey, it's getting dark. We need to get sleepy. We got sleep to do, dreaming to get done. We got to reset the body, so then it starts producing melatonin.
Yeah, absolutely. And so that's in the optic nerve, right? The rods connect to the optic nerve.
Yep.
And, okay, so little quick recap here. Rods connect to bipolar cells,
yep,
which connect to ganglion cells,
Woo!
which connect to the optic nerve.
The ganglion cells converge together to form, it's almost like a braided rope.
Okay.
Yeah.
So the ganglion cells converge and then form the optic nerve.
Yep.
Which part of it goes through the hypothalamus in order to communicate with the pineal gland.
Yep.
And then the rest of them obviously go back to the occipital lobe.
Exactly.
Cool.
And so conversely, in the light, like maybe you didn't close your blinds as much as you wanted to, and that very early Saturday morning after a very fun Friday night, the sunlight hits your eyes and you're like, oh my goodness. So when light hits our retinas, because they do partially connect through the hypothalamus, light signals for the hypothalamus to release corticotropin releasing hormone, so CRH, that stimulates the release of adrenocorticopic hormone from the anterior pituitary, and eventually from that, it stimulates the release of cortisol from the adrenal glands.
Yes.
So there's like 3 levels there.
Specifically in the cortex, right?
Yes.
Adrenocorticotropin. I only pointed that out because when I was taking physiology and we were learning about hormones, I felt really smart at that point. I was like, oh, adrenocorticotropin is cortex in the adrenal glands.
Exactly. And what the medulla produces epinephrine and norepinephrine or something like that.
I thought those were also in the cortex. Doesn't the adrenal medulla produce aldosterone? And
correct us at the Twitter we don't have.
Yeah, exactly. Tweet at us what the adrenal medulla does.
Yeah, we're super ready for this, guys.
You can tweet at us at we don't know anything, at MCAT. Tall and Small, at MCAT, at Salcon is awesome, at audioboxusb.com.
There we go. So we're gonna skip on to dreaming.
Yes.
And so we really don't know why we do this. Like, we've been around for a long time and lots of people have given ideas, but we're not really quite sure. And so the 3 most common theories the MCAT wants us, the AAMC would like us to know. I always personify the MCAT like somehow the test is telling me what I need to know. But so the first theory on why we dream would be activation synthesis theory. And that one, the name doesn't make a whole lot of sense, but I always think about it as just active neurons randomly firing. And so that's just literally the random activation of neurons. Activation synthesis theory. Somehow by activating random neuronal activity, we will create something in our noggins that we perceive as dreaming. And so the second one would be problem-solving theory, which I really like. I think it makes sense in an evolutionary context too, that we sleep in order to get out of some of our little boxes on how we think about problem-solving. So we don't have a mental set maybe when we're sleeping. we're able to think about things in a different perspective and we can see new solutions. So the problem-solving theory is the second theory. And then the cognitive process theory is just the sleep version of stream of consciousness. And it's just kind of, we dream about things because like our brain is still active when we're sleeping, and
Right.
yeah, things
And
just are passing through our brain.
So it almost seems like that one means like we have to be, well, it goes back to the very beginning where we talked about consciousness is our brain's like place in the world, kind of.
Yeah.
And that it always has to have a place in the world.
Yep.
And we have like the 4 states that are just umbrella terms for like how your brain could be in the world.
Yep.
So then I guess during dreaming, it just, you know, it can't be dead.
Right.
It's got to be doing something. So
I'm still alive.
yeah, exactly. It's kind of weird.
You're gonna think about your 3rd grade teacher in his underpants eating pizza on the Empire State Building with what's the giant gorilla?
Oh, King Kong.
Yeah, there you go.
Because you got to think of something.
Yeah.
This is all you're gonna get.
Yeah.
You could fly. Oh no, we're gonna make you dream of this weird thing.
Yeah. Thanks, brain.
Thanks, brain.
So the next fun thing we could talk about is sleep-wake disorders. So a dysomnia would be a problem either like staying asleep or going to sleep or staying awake, which I think is a fun one to talk about, but I'm sure is actually really difficult to deal with if you have it. And then parasomnias, and those would be problems that you have while you're sleeping. And we will also get into those. We've talked about them already as well.
Oh, I like so in your notes you have parasomnia, weird stuff during sleep.
Yes.
So para kind of meaning like if it's parallel. Like if you have two, in my head I'm seeing now 2 lines. Like you have a line where you're asleep and you have a line that's weird stuff that's happening, but they're occurring simultaneously.
Yes. And so it's good that you brought that up. One of the dysomnias we're going to talk about is sleep apnea, which almost seems like it would go along with the parasomnias because it's while I'm sleeping, there's a cessation of breathing while I'm sleeping.
Mm-hmm.
And that makes me think, you know, that it would be a parasomnia, but it's not technically, I think, because it does wake you up when it happens.
Yeah.
And so it's a problem staying asleep. So that's why it's classified as dysomnia.
Yeah. And in my parallel lines thing, I guess a dysomnia, like if you had sleep apnea that was constantly waking you up, would be like when it wakes you up, when it actually disrupts the sleep. That's like, an intersection of those 2 lines.
Okay.
Like
or
the
like
dysomnia.
breaking
It breaks
sleep
it.
line.
Yeah, the sleep line is going and then boom, it gets broken by the dysomnia.
Yeah.
Or like in insomnia, it's like messing up the sleep line for a long time in the beginning, then eventually you can get there.
Yes.
Or narcolepsy, where the sleep line appears in the middle of the day.
Yeah.
Out of nowhere.
So Tal mentioned a couple of them already. Actually, I think he mentioned all of them. But we'll very quickly just give the very basic definitions because not everyone has been able to take a class where they talk about sleep before. Mm-hmm. Which is weird because it's something that all of us do. So we should mention it, I think, more in biochem. I think it's important.
It seems like it should be something not only in education, but also in normal medical practice. Like,
yeah, and
why
health.
isn't sleep focused on more?
Almost half of our, not half of our day, not for students, at least not for us pre-meds, but yeah, it's quite important, I would say.
Yeah.
So the first one, it would be insomnia, which I think a lot of people, I think that is probably the most common one people have heard about before. Mm-hmm. And so hard to fall asleep. So there's a commercial I always see, Lunesta or something like that, that helps people fall asleep.
Okay.
I know people take melatonin to help prepare you to fall asleep, maybe make it a little easier. And it's very common to have prescribed sleep medicine to help you fall asleep because a lot of people have problems with it.
Yeah.
So narcolepsy would be the opposite, where the people can't control when they go to sleep. And so I kind of thought that maybe it just happened randomly or something, but apparently it happens when they get upset or scared or you know, some sort of emotional change happens.
I've seen it as a reaction, like a defense mechanism almost. I knew someone one time who had it and like kind of grew out of it.
Okay.
I guess that's a thing. But he said when he was a kid, it would be like sometimes in school. It's normally coupled also by people who have anxiety problems, who have those kind of things. So maybe when you can kind of get over some of that stuff, the narcolepsy starts to not become an issue.
Oh,
but,
I saw a practice problem that was mentioning why biologically it might happen.
Okay.
And so I think the answer ended up being like when these people fall asleep, they literally fall and so they become horizontal, and there's more blood flow to the brain.
Oh, wow.
And I'm having source amnesia right now to get meta with our psychology references.
Yeah.
But I wish I could remember where I got it from and know if that's accurate.
Yeah, I'm not sure.
But it would make sense.
It would, yeah. All I knew was that the guy that I knew said that it happened whenever, like, whenever he would start to think about too many things, and like, that, as I'm sure a lot of people can relate to, like a kind of spiral of anxiety gets getting bigger and bigger, and then his reaction is just to kind of like put his head down, and then boom, he's asleep.
Oh wow. Yeah.
It's like you can't even control it. You just go down and you fall asleep.
Yeah. So the last one on here would be sleep apnea, which we said was the cessation of breathing.
Mm-hmm.
And it is actually characterized as a dysomnia because it is something that inhibits you from continuing sleep. And so because it breaks it up, it's the inability to stay asleep. So it falls under that third category of a dysomnia.
Mm-hmm.
And so we already talked about both of the parasomnias, night terrors, and somnambulism, which is sleepwalking. And so in my notes I said weird stuff during sleep, as Tal said,
Mm-hmm.
which helps me remember it. We mentioned already that it's the most common in kids because they have more slow wave sleep. So it's like intense anxiety, thrashing. The child screams like they're being possessed or something. I mean, it's terrifying for these parents, especially if it's your first kid.
Yeah.
And then somnambulism can be just as scary because people can eat, talk, people can have sex, people can drive different places and wake up and remember nothing.
Wow.
Yeah. And so you ended up in the street one time.
Yeah, when I was about 3 or 4 years old, I got out of the house, ended up in the street, and my neighbor had me in his arms, knocked on my parents' door, and said, "I found this."
Oh my goodness. See, that would be terrifying for a parent as well.
Yeah.
So I have a funny story for sleepwalking. Apparently, I think I was in middle school, or maybe my first year of high school. It was Thanksgiving or the day after, and I walked into my parents' bedroom at like 2 or 3 a.m.
Mm-hmm.
And I told them that there was a turkey platter running up and down the hallway. And my mom was highly annoyed with me, as I'm sure a lot of mothers would be. And my dad got up and checked.
Well, honey, okay, she's probably sleepwalking, but I need to make sure. I have to know. I'm not going to be able to fall asleep unless I know about this turkey platter.
So another cool altered consciousness thing that I think we need to talk about because it's important is hypnosis and meditation,
Yes.
which Tal actually knows a lot about.
Mm-hmm.
And there is actually some validity in both of these for a treatment for certain things. So I will let you take the mic.
Yeah, so I used to teach meditation at a clinic that I worked at, and I've practiced different kinds of meditation for a very long time. Herbert Benson's The Relaxation Response. He was a Harvard researcher from Harvard Medical School in like the 70s or 80s, something like that. But he went to Tibet. He met all of the monks there, and he wanted to just learn, like, why do you seem to have better health, and does it have anything to do with this meditation? And so he took lots of different vitals on them, and learned that when they go into meditation, they are in fact eliciting a what he called the relaxation response versus a stress response. So we have like a sympathetic, like, kick on the high gear, like we need cortisol flowing, we need everything to be active.
Yeah.
And then we kind of always thought of parasympathetic as like, that's just your resting state, that's, rest and digest.
Yep.
But it, he kind of described whether or not you could really attribute this to an actual state of being. He described a common state between these monks that they were producing like higher skin temperatures. They were producing all kinds of different hallmark biochemical pathways that were changing in them when they would do this meditation. Their heart rate would slow down like crazy. It was almost like they could control their autonomic nervous system.
Wow.
To go even further relaxed than what parasympathetic would normally allow. So it's got so much beneficial use, especially with just teaching your body how to be calm again, because like a lot of pre-meds know, constant stress it's not just, oh, I'm stressed. You're actually hurting your body, and your body's not, it won't remember what does it mean to actually function in a non-stressed, state of being. And then hypnosis, I had a cool experience with this. I've seen professional hypnotizers. I can't even remember what they're really called. Hypnotists.
Hypnotizers.
So I've seen a professional hypnotist who had, and this was weird because a lot of people think hypnosis is like you're completely in a trance or something like that. That's not really what it is. They always use the word suggestion, like someone is suggestible when they're in this state of hypnosis. And it's kind of the same way that you can get people, like they often talk about like political rallies, like, Hitler was so good at commanding the audience with the way that he talked. It was almost a kind of hypnosis. And all of the hypnotist people that study it, they all point to people who can talk like that, or people. Tony Robbins is a good example. Whenever he does his huge speeches to tons of people, like motivational speaking kind of stuff, they're almost in a stage of hypnosis because they've said, yes, I am going to allow you to kind of control how I'm thinking. And that's what hypnosis is. Even from a medical perspective, if you have someone who has like a behavioral disorder, you talk them into this state of suggestibility, and they're conscious, but at the same time, they've kind of slipped out of their
alertness stage.
Yeah, it's I guess it's an altered stage of consciousness where what I saw was the lady said, like, I could get him to lift his hand just off the table, which, that doesn't really have any medical significance, but it kind of lets you understand. And, she spent about 10 minutes just talking to him, and you have to be willing to want to do it.
Not skeptical.
Exactly. So he was willing to. He's like, yeah, just, I'll see what you can do. And so she like talked him, and he got nice and relaxed. If anyone does yoga, it's kind of like in Shavasana at the end. You're being told to relax, and they'll say, like, relax your arms, and then relax your forearms, and then your fingers. And if you just do it, you kind of really start to fall into this relaxation. So it was the same thing with this guy. She started to say, talk about his fingers not weighing much, and she started to just slip in these things like, there's something pushing your palm, and you could kind of see his hand like almost like pulsing a little bit, and then soon he was kind of lifting his fingers. They were shaking a little bit, but he was like lifting his fingers like a jellyfish almost off the table. And then eventually she kind of like brought him back down, and he put his hand back down, and when he woke up, he said, I guess I kind of knew it was happening, but I didn't feel like I was in control.
Yeah. So they use this a lot of times with people who have chronic pain, when it is not desirable to keep pumping them full of pain meds. And so a lot of physicians look for any alternative they can give said patient that doesn't require them to be pumped with a lot of medications. And so this is one, if the patient is willing and not skeptical, then it could be something that helps them without pumping their body full of something that could be harmful eventually, that their liver has to keep breaking down. It could actually help some people, like people with chronic back pain. Yeah.
So speaking of drugs.
Yes, that is our next section would be consciousness altering drugs. And so really quickly, let's define one more time what is consciousness.
So consciousness would be basically your perception of the world at any point in time. And those points in time can be defined typically as stages, which a stage of consciousness is kind of is your consciousnesses like its function as a result of your physiological state at the time.
Yeah.
So if your body is chock full of melatonin and your cones your rods are sending a signal to your hypothalamus and all this kind of stuff, then your consciousness is going to be sleep.
Yeah.
So that would be kind of the times, the different states that your consciousness would be in.
Exactly. And so drugs that are consciousness altering are things that can change how you are physiologically and I guess psychologically as well,
Mm-hmm.
in different stages. And so even though you're alert, you might not really be alert. You might be experiencing altered consciousness due to these drugs. So there are 4 major classes, and then marijuana, however you want to say it, Mary
Its own
J.
class.
Yeah, because it acts like 3 or 4 different drugs at the same time, which I think is really interesting.
So what's the first one?
So the first one would be depressants. And so these work on your GABA receptors, which, immediately when you see GABA, you need to think that's one of my major inhibitory neurotransmitters.
Mm-hmm.
And it works by, GABA receptors work with chlorine channels, and so it allows chlorine to flow in because it is higher outside of the cell. So it allows chlorine to flow into the cell, and then you hyperpolarize. So it is much harder to get an action signal an action potential to go off, and you start decreasing synaptic activity, kind of all over the brain.
So when you typically have an excitatory neurotransmitter, when we think of serotonin getting released into the synapse, and sometimes people literally just think like they know everything about the presynaptic neuron, and then they just know that the neurotransmitters go out, they hit the postsynaptic neuron, and then it just gets transmitted.
Yep.
But it's sodium channels, right?
Yep.
And possibly calcium. Well, I know at least sodium.
Yeah, calcium is definitely involved. When I think of calcium, I immediately think of at the axon terminal for getting rid of the synaptic vesicles.
Yeah.
And
but either way, it's a positively charged ion.
Yes.
Therefore, it's going to depolarize and
Send the
push
action
that action
potential.
potential.
It is really interesting that you bring up calcium, though, as far as signal transduction and potential long-term potentiation. That is the phrase I was looking for.
Mm-hmm.
When you use a specific neuronal pathway enough times, it will, and actually, it is a, what is it called? A GPCR receptor.
Okay.
And so, the more you use a certain pathway, at the end of this specific GPCR camp pathway, it will increase something called CREB, which is like camp response element binding protein and something, and it gets phosphorylated by pKa, and it sits on the DNA thanks to help from another protein. And anyway, the end of this CREB pathway in the nucleus from a GPCR receptor is to increase calcium receptors that are put into the postsynaptic synapse.
Right.
So the more of those that you have, you actually respond more the next time the same signal comes down that neuronal pathway.
So it's quicker.
Yeah. So anyway, calcium for sure plays a part because what is it? In MDA, and there's another AMPA. AMPA is the other receptor. So anyway, you can have a sodium and a calcium response to a neuronal signal on the postsynaptic side.
Mm-hmm.
So yeah, so the calcium can play a role, and that is that long-term potentiation that we just talked about. I'm sure I haven't gone over that in a minute, so that was a little choppy.
Yeah.
But calcium can totally play a role, and that allows us to form memories. So that's really important in our hippocampus.
So as that relates to depressants, though, the idea that if gamma aminobutyric acid, which is GABA, acts on chloride channels,
It would be the exact.
it's the opposite.
Exactly.
We let in positive ions normally, or
Yep.
not normally, but with excitatory, we let in negative ions with inhibitory.
Yep. And so a good way to remember that is just to remember your very basic neuronal signaling thing, which is that when an excitatory neurotransmitter binds to the postsynaptic side, a receptor on that side, then, sodium rushes in. Well, what is sodium normally present as when we bring it into our body? Oh, it's, in salt. It's in a salt form, so it's NaCl. So Na and Cl are both higher concentrations outside of my cell.
Yeah, exactly.
So GABA. So that was a really long way of saying that GABA works on chlorine receptors and allows these chlorine ions to flow in and hyperpolarize the cell and make it harder for any neuronal signaling to happen. So therefore, it's classified as inhibitory.
Right. So alcohol is the one that I always know about
Yes.
with depressant, as far as specific examples.
Yeah, that is the one I think most people do remember. From a sociology standpoint, I think they want us to know that alcoholism is more common in lower socioeconomic areas, which I think kind of would maybe make sense. But people in lower socioeconomic areas are more likely to get help when they realize that they do have alcoholism, versus people who develop it and are in high socioeconomic areas.
Right.
Maybe it's a stigma thing.
Yeah.
It definitely differs based on culture.
Yeah.
Yeah. But anyway, back to the biochem side of things. It just it does the same thing with the GABA receptors. Anyway, it's our best example of a depressant.
Right. Yes.
Another thing that people think of when they think of depressants would be barbiturates and benzodiazepines.
Those guys are nasty.
Right, and so they are prescribed for reducing anxiety or sleep help. Do you know anything additional about them?
I think Klonopin is one.
Okay.
And I know that. I know that basically they can get very addictive. And they essentially make you seem like you're drunk.
So do they kind of dull everything?
Yeah.
Okay.
From how I understand it, and tweet at us at our non-existent Twitter if I'm wrong. I have immunity by not having Twitter. But I believe that barbiturates, benzodiazepines are they literally just make it like you're drunk, like you just can't kind of focus on anything.
And so maybe there's an emotional component to that as well.
Could be.
So one of the terms that they used was alcohol myopia, which is short-sightedness. And this is actually how I remember myopia in the eye as well. I remember it short-sightedness from this example. And so that is, you are unable to consider the consequences that might arise from your actions when you're in a state of altered consciousness that the drug of, the most common drug that's like abused other than caffeine, so alcohol, it kind of places you under this altered consciousness. So yeah, actually, that's a good thing to mention, that alcohol, is so common, and there's probably less of a stigma on it than other drugs, but it's the most commonly abused because it is so common.
Right.
That and what I'm drinking right now, caffeine.
Yeah.
So the second form of consciousness altering drugs would be stimulants. And so when I think of stimulants, I think of meth, like in health class growing up, and people are like crazy and shaking and itching scratches all over their body, and they feel like bugs on them and stuff. That's what I think of when I think of stimulants. They increase arousal. And so amphetamines, cocaine, ecstasy.
And that would include things like Adderall and Ritalin, right?
I would assume so.
I think so.
Yeah.
Because I'm pretty sure those are amphetamines. And
oh yes, I think so.
Huh. Yeah, those things are nasty. Like, people need to be really careful.
And I think they're probably also pretty commonly abused as far as like the pre-med
as people who
species know.
I'm sure everyone at college, especially if you were in an academically rigorous environment, you've seen this before, that there is definitely a problem with people abusing this and people selling it on college campuses. And it's a big deal, and it's not something to be taken very lightly.
Yeah, I had a friend who would use it to stay up and do her homework, and then in the morning, if she didn't sleep that night, she would use something like Xanax to calm herself down to maybe get some hours of sleep before she went to her next class.
Artificial circadian rhythm.
Yeah, so it's almost a nocturnal lifestyle, and you're just artificially keeping yourself going.
That's nasty stuff.
Yeah. So back to stimulants. So we said that depressants work by inhibiting, or they are affecting GABA receptors.
Yeah, they increase GABA activity.
Right. So it's an inhibitory thing for neuronal signaling. But stimulants, they increase dopamine, norepinephrine, and serotonin, and decrease their reuptake. So they increase all of this. So I have to think of it in really simple terms with these neurotransmitters. So dopamine gives me my surge of happiness, right? My good feeling.
Yeah.
And then norepinephrine is one of my like adrenaline-like drugs, so I'm really amped up.
Right.
And serotonin, I think I don't necessarily know what serotonin does.
Serotonin does a lot of things.
Okay.
It's very confusing to me as well.
It's like mood, sleep,
yes,
sex, maybe something like that.
I know mood, sleep, sex, and like eating
Yeah.
are all involved with serotonin, but from what I can gather, at least for as it goes in, with the MCAT until we get to psychiatry rounds in the third year of med school, what we need to kind of know about serotonin is its job is to kind of keep you at your normal like homeostasis, I think.
So the hypothalamus probably uses it for lots of things.
I would assume.
Okay.
Yeah.
So for all of these stimulants, they increase dopamine, norepinephrine, and serotonin and decrease the reuptake. And so we talked about amphetamines. I mentioned meth from health class, reading, or I guess we watched a lot of videos about it because I have some good visual episodic memory about it.
It's also kind of
scary stuff.
It's kind of ironic that they would, when we were kids in health class, they were teaching us about how bad amphetamines were.
Yeah.
When maybe a quarter of us were on Adderall or Ritalin.
To get us to sit down and be quiet. Yeah. Cocaine is another one of a stimulant. I think they showed this one a lot in party scenes, right? In movies,
yeah.
People would take cocaine and stuff like that. And
say hello to my little friend.
Yeah. And the bathroom of parties and things like that. It makes me think of Narcos on Netflix, which is a wonderful show in case anyone is Spanish-minded. I love that show. Okay, Escobar and all that business. So ecstasy is another example, although I think there's a hallucinogenic component to ecstasy as well.
A little bit, yeah.
Okay. And so we'll come back and we'll do like a very quick, brief overview of each one of these because I think we're going off on little tangents, but I think they're important for us to process all of these.
Sure, yeah.
And so the third type would be opioids and opiates, and they are derived from the poppy flower. Is it a flower? I know it's a plant.
It's literally the only reason I would think it's a flower is because of the Wizard of Oz.
I know, I was about to say that.
But I do remember growing up that when I was watching Seinfeld, Elaine had a poppy seed muffin and then was trying to get someone else's urine because she thought she would fail the drug test. I can't remember if she does, but she tries to get someone else's urine because she ate a poppy seed muffin and someone said like that's going to make you fail the drug test because it'll show up as opioids. Oh,
okay. So the examples that were given were morphine, codeine / oxycodone, and heroin. So I think opioids so opiates maybe are the natural ones, and then opioids are the ones that are partially synthetic or something like that. But they have basically the same function. They're given for I think most commonly probably given for after a surgery or something like that when you need really strong pain meds.
Yep.
But unfortunately, this puts people at a tendency to become addicted to them because they do help so much after you've had a lot of pain. There's a tendency to want to stay on that crutch. And so they bind to opioid receptors in the nervous system and prevent pain signals from being sent.
Yeah, they work well like that. Also, do not worry about eating poppy seed muffins before you take a drug test. Seinfeld literally made that an urban legend. It's not true. It's not going to make you fail a drug test.
Okay, that's good to know.
Yeah.
So the fourth type would be hallucinogens. And so they think that what does this would be increased serotonin, but they're really not quite sure what does it. And so the most common ones would be LSD, peyote, and mushrooms. What are they called?
Psilocybin mushrooms?
Yeah.
Discovered by Andrew Weil. I like mushrooms.
And so they stimulate your sympathetic nervous system. Lots of things going on in your noggin. And that is the four major types. So we'll go over them really quickly. Just not all the examples again, but what type they are and then what their physiological function is, or basically their biological function.
Yes.
And so I'm going to quiz you now.
Okay.
I'm going to put you on the spot.
All right.
Depressants, what do they do?
Depressants increase GABA activity, which increases the influx of chloride which basically puts negative ions inside the postsynaptic neuron, which hyperpolarizes to combat any kind of sodium positive rush that could be happening.
Yep.
And I know alcohol is one, blah, blah, blah. But What else do you want me to say about it?
Oh, well, I was just going to be careful because it's not excitatory. There would probably not be an influx of sodium.
Well, I mean, like, if you had, let's just say there was a combination of, I don't know, dopamine,
Yeah.
but also there was GABA.
Yes.
So GABA would hush down the sodium influx.
Okay.
Because I know that a lot of times you have multiple neurotransmitters being released into a synapse at the same time.
Yep.
Okay, so then the next would be
stimulants.
Stimulants.
Yes.
Stimulants, amphetamines. They act on norepinephrine, serotonin, and dopamine.
Yep.
It basically just gets you going and gets you moving and gets you like very.
What neurotransmitter is responsible for my rush of euphoria?
Rush of euphoria, dopamine.
Yep.
Okay, that's what I would think.
Yeah, and then what would be the one that is most important in sympathetic stimulation?
Epinorepi.
Yep.
Okay.
Yep, which is adrenal medulla.
Yes. Adrenal medulla.
I may or may not have Googled when Tal was telling a story. And then the next one would be opiates and opioids.
Opiates and opioids.
We did not talk about specifics. It's kind of in general what it would do.
Yeah, they block pain receptors.
Exactly.
They're very powerful for that. Also extremely addictive.
Yep. I think the town I come from in Tennessee is like #1 in the nation for opioid addiction or something like that.
It's kind of crazy.
Yep. There we go. Had to be famous for something, I guess.
Yeah.
Just not a good one. But hallucinogens.
Hallucinogens, they think might be because of increased serotonin.
Exactly. Not super sure.
Yeah, LSD, mushrooms, peyote, things like that.
Yep. Okay. And then the fifth one would be, commonly referred to as weed, marijuana. And it wins its own category for being classified as a stimulant, a depressant, and a hallucinogen. So the active ingredient is THC, which is tetrahydrocannabinol. Did I say that right?
Tetrahydrocannabinol.
Yeah. And so the MCAT would like us to know that it is involved, drug addiction in general is involved with the mesolimbic reward pathway. And I don't think we need to get in the specifics of, that pathway. But I think it's important to know that because these drugs, a lot of them, have at least something to do with dopamine, and there is a rush of euphoria, or maybe it's a depressant and it dulls emotional things so much that they can become a crutch. And so the good thing becomes like a reward thing in our brain. And so it's part of a reward pathway.
Yeah, and when you said mesolimbic, you also said motivation and emotion in your notes. And whenever you think limbic, definitely think emotion.
Yeah.
Like more basal, motivations, emotions, things that, feelings, limbic system.
Like my motivation for not feeling upset would be to turn to whatever my drug of choice is.
Exactly.
Okay.
That's where the addiction messes with your emotions. Rather than it just like, ooh, it feels really good. It's like now it's like you said, your crutch.
This almost goes into avoidance learning where, we're studying right now because we want to avoid getting a bad grade on the MCAT, whereas someone might learn to drink a lot of alcohol when they get really stressed out at work because that's what decreases the negative thing for them.
Okay. So that would be mesolimbic.
Yeah, and it would reinforce the behavior because it does something they would like to, it removes a stressor for them.
Right.
Yeah.
Okay.
Well done, Tal.
Yeah.
Strong work, gang.
Ooh,